So we need to determine the radius and interval of convergence of the given series. So the sum of the series equals x to the power of 2 times 1 minus 1 over 1 factorial over 1 squared, minus x to the power of 2 times 2 minus 1 over 2 squared plus x to the power of 2 times 3 minus 1 over 3 squared minus x to the power of 2 times 4 minus 1 over 4 squared, and so on. So we can represent it as the sum of negative 1 to the power of n plus 1 over n squared times x to the power of 2n minus 1, where n goes from 1 to infinity. We will apply the ratio test. So we need to find a n, the nth term of the series. It equals negative 1 times to the power of n plus 1 over n squared times x to the power of 2n minus 1, and n plus 1's term. So n plus 1 equals negative 1 to the power of n plus 2 over n plus 1 squared times x to the power of 2n minus 3. Then the limit of the absolute value of n plus 1 over n, where n approaches infinity, equals the limit of the absolute value of negative 1 to the power of n plus 1 over n squared times x to the power, here we have n plus 1, so here we have this expression. I'll just copy paste it. Here we have this expression divided by n, so here we have this expression. And n approaches infinity. Now we will try to simplify it. This equals the limit of the absolute value of negative 1 times n squared over n plus 1 squared times x squared, and n approaches infinity. Then this equals the absolute value of negative x squared, and we know that our series converges if this is less than 1. So we get that the absolute value of negative x squared is less than 1. So the absolute value of x squared is less than 1. That means that the absolute value of x is less than 1. So the interval of convergence is x lies between negative 1 and 1, and the radius of convergence